Hello guys, welcome to Pepcoding. Today we are gonna solve this question: cycle node in linked list. So there are two things which you have to understand first. That before doing cycle node in linked list, we have to do is cycle present in linked list. There's a question: is linked list cyclic? So and I will show you. So this is cyclic. Okay, we will go down. Okay. Fold, unfold, then reverse, copy linked list. Is cycle present in linked list? This is a question you have to do before this question. Okay, this is cycle present in linked list is the prerequisite of this question. So go there, check that out first. And the second thing is, Rajnisha already did the mathematical proof for is cycle in linked list. So check that out also. After that, come to this video. Now let's get to our open board and I will tell you the question statement, and after that you will gonna understand its approach. Okay, so let's start now. So I think this is a linked list. This is a linked list we have given, and this is the cycle which is present in our linked list. This is the cycle. Okay. So what we need to do here is we need to return this node. We need to return this node, the node from which the cycle is starting. Okay, this is the node we need to return. This is the question statement. Now comes now if you remember, now comes the approach part. But before that, if you remember, there was a formula we have derived. Rajnisha have derived in the mathematical proof. So we will start things from there. So this is A, and this is the A. Here is B. This is B. If for example this is meeting point. Meeting point. This is B. Then this is C. So if you remember this formula we have derived, which is A is equal to C plus M minus 2n minus bracket B plus C. And what is M here? Is number of rotation of fast pointer before meeting point. So number of rotation our fast pointer will take before meeting point is M, and N is what? Number of rotation of slow pointer before meeting point. Now you got given that first is this our formula. So everything is dependent in this formula. So first thing is, what happened if B plus C is 0? What does it mean if B plus C is 0? B plus C is equal to 0 means no cycle. Means there is no cycle present. Right? If the length of B plus C is 0, that means there is no cycle present in the linked list. Right? So the linked list is linear at that time. So we cannot do anything. If cycle is not present, what is the starting node? No starting node. The second condition is A and C can be 0. A and C can be 0. Okay. But the thing is, if A is 0, C must be 0. Means A and C can be 0, but if A is 0, C must be 0. Why? Understand? If A is 0, then our equation C plus M minus 2n minus 1 B plus C should be equals to 0. Right? So there are two terms. This cannot be equals to 0. So either this will be this have to be 0 and this have to be 0. So if C is equal to 0 and this is equal to 0, then only A can be 0. Okay. Now understand two concepts. Now comes the main part. Think it like this. We have, so if A is 0, then C is 0, and also M minus 2n minus 1. This should be equals to 0. Right now, this should be equals to 0. Now comes the main part. Here n is either smaller than 1 or n is greater than equals to 0, right? So if n is if n there are some things that before meeting point should be smaller than 1 and n should be greater than 0 equals to 0. That means what? Is equal to 0. That is the only meaning, right? So here if n is equal to 0, I can say m minus 0 minus 1 is equal to 0. So I can say that m is equal to 1. I can say if n is equal to 0, m is equal to 1, right? That means only one rotation before meeting point. M is equal to 1 means one rotation before meeting point. So let's take an example. This is slow, this is fast. We move something like this direction, right? So if this is my meeting point, I can say that S will take 1 round and F will take 2 round. But the thing is, F is not taking 2, F is taking exactly 1 and S is taking 0. So the second round, F will meet. So second is not considered, right? And the second example is this. Okay. So slow is here, fast is here. We move them. So let's move slow. Slow go here, fast go, come back to here. So one round is done. One round for fast is done. In the second round, slow go to here, fast, then again and come back here. But at second round, what happened? This meet the S. So in second rotation, F meet the S, so that is not considered, right? So here also S is equal to 0 and F is equal to 1. Let's take an example of 3 point. 1, 2, 3. This, and this. Okay. So S is here, F is here. Right. So take. So move F as first. Let's move F. Let's move S. Let's move F. One rotation is done. Let's move S. Let's move second rotation. They again met. That means what? Is equal to 0. F is equal to 1. Right? Now from these things we can derive our formula to this. That A is equal to C plus M minus 1 bracket B plus C. I can say that, right? I can say that. And M is number of rotation before meeting point, if you remember. So here you can see that if, let's see, if M is equal to 1, I can say that A is equal to C. Because if M is equal to 1, this term will be 0 and A is equal to C. Second point. What if M is equal to 2? If M is equal to 2, then A is equal to C plus B plus C. And the same scenario here, that if M is equal to 3, A is equal to C plus 2 B plus C. There are 3 things here. Now let's do a dry run. You will understand what I am trying to say. So let's make a linked list here, something like this, and then let's take it. So I have to do like 1, 2, 3, 4, 5, 6, right? And then again 1, 2, 3, 4, 5. So from here 1, 2, 3, 4, 5. 1, okay, 1, 2, 3, 4, 5. Say 1, 2, 3, 4, 5. This will be our meeting point. Let's check it out. I'm saying right now that this is our meeting point. Let's check how. So I'll take a F, and then I'll run them. Let's run S once. F will go 2 times. Then again S will run 1. F will go 2 times. Then again S will go once. F will move 2 times. Again S move once, will move to 2 times. S will move once, F will move to 2 times. Again S move once, F move 2 times. Again S move to this point. Now I get to my meeting point. Can you see? So how can I say that? How I previously said that this is a meeting point. I know, because if you remember, this is our C, right? And here if M is equal to 1, M is equal to 1, A is equal to C. That means jumps from 1, 2, 3, 4, 5. Number of jumps are 5. So A is equal to C, right? This is A. C will be same, something like 1, 2, 3, 4, 5. Again 5, right? Okay, so if you understand this, that's fine. But if you don't, we will do it again. Now we will discuss about the second case, which is M is equal to 2. So for that, what we will do is we will make it a little lengthy. And first let's erase something. So this is not fast now, and this is also not our meeting point. Okay, so remove it. Let's take this as a meeting point. And this is C. C is this till here. So 1, 2, 3, 4. Okay, value of C is 4, right? And 1, 2, 3, 4, 5. Let's make 6 node more here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. So let's take the example of second node now. Sorry, second case. So for second case, let's take again slow and fast and start to move them. So slow 1 time, fast 2 time. Slow 1 time, fast 2 time. Again slow 1 time, fast 2 time. 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 Here, one rotation of fast is done. Okay. So slow 1 time. Let's move fast 2 times. Then slow 1 time. Now fast 2 times. Then again slow 1 time. Fast 2 times. And again slow 1 time. Fast 2 times. Here, 2 rotations of F fast point is done, right? And when S goes to a meeting point, this is our meeting point, right? So when M is equal to 2, A is equal to C plus A, C plus B plus C, right? So there's one thing which you can see is, so if this is a meeting point, and what I do, I pick my slope from here. I pick my slope from here and I put it again here. So you know that till if I run S from here to here and F will rotate like this, we know that A is equal to what? C plus B plus C. So if I run, so let me show you F one time and F one time, S one time, F one time, S one time, one time, S one time, F one time, S one time, F one time, S one time, F one time, S one time, one time, one time, F one time, S one time, F one time. Now see what will gonna happen here. One time, F one time, and here both the character will meet where? At here. And if you remember, this is our node which we need to find. If you remember what we did, what we actually did is when our S and F are like this, right? So we take S from here and put it here, and then if we iterate again and again, at eventually F and S will meet at this point, right? So now let's code it out, and then this question is done. So let's code it out. So okay, let's reload it. So let me make it a full screen. Let me increase the font size also. Okay, oh, it's full. So let's make it full screen. So this is our function. Let's put our initial case, which is if head is not even there, null ptr, or if head dot next is equal to null. If there is no head, or if there is only head, there is no linking, there is no cycle, right? Return null ptr. After that, we have to make our fast and slow, right? So list node asterisk slow is equal to head. Again list node asterisk fast is equal to, then again while loop fast is not equal to null ptr, and fast of next is not equal to null ptr. After that, slow is equal to slow of next, and fast is equal to fast of next. So what we did right now, till now what we did, let me explain you. So here, first of all, we put our base case here. So if there is no head, it means there is no possibility that there can be a cycle. So we return what? Null. After that, we initialize our slow pointer and our fast pointer, because now we want to know if B plus C is even there. Like if there is any length, if there is any cycle. Now this loop will be to detect if there is cycle, if there is any cycle possible or not. So we initialize slow and fast, and then we move them fast with 2 times of the speed of slow, right? And if anywhere slow is equal to fast, if they meet, they will break. So now if you understand the code a little bit, so there are 2 possible ways that our loop will break. First is our fast will get null, or second is fast dot next next of fast will get null. The third point is if slow is equal to fast. So if slow is equal to fast, then there is the possibility that there is the cycle present. So we do that. So if slow is not equal to fast, that means what? There is no cycle. So we will return null ptr, right? But now the remaining part will be for cycle. Okay, so we do what? First thing we do is make slow as head. right? And now while slow is not equal to fast, we do what? Slow is equal to slow of next, and fast is equal to fast of next. And after that, what we need to return? We need to return slow, right? Because now there's no don't listen. You can return slow or you can return fast. Both are at the starting point of our node where the cycle will start, right? So now let's try to run this code and check if there's any compilation error. Let's run this. Accepted. Let's submit it. Very correct answer. So if you like the video, if you like my explanation, please like the video. If you have any query regarding this question, please comment it out. Subscribe to our channel. Thank you so much, guys.